Welcome to this video. In this video, we'll look at three statements and we'll check whether they are true or false. What is the statement? First statement says every whole number is a natural number. Second statement says every integer is a rational number. Third statement says every rational number is an integer. So we will check whether any of this is true or false. Shall we start? To solve these problems, we will use this diagram. So let's go through this diagram. What is a natural number? The natural number is things that we can count, let's say using our fingers. So then appear naturally in the nature. So we start with 1 and 2, 3, 4 and so on. So it just goes on 1, 2, 3, 4 and so on. What's a whole number? A whole number also has 0. Okay, the whole number also has 0. So it is 0, 1, 2, 3, 4 and so on. So whole number consists of natural number as well. What's an integer? Now an integer includes the positive integer, which is 0, 1, 2, 3, 4, so on. And it also includes negative integer, which is -1, -2, -3 and so on. It does not include fractions. It only includes integers, which is negative integers and positive integers and 0. And then we have rational numbers. Now rational numbers include all of the integers, but it also includes fractions like half, -3/4 and 9/5. So rational number includes integers, whole number, natural number and fractions. Then we have irrational number. Irrational numbers are numbers which cannot be represented in p/q form. Things like pi, √2, exponential constant e, they are all irrational numbers. There are many more. These are the examples. Now the rational numbers and irrational numbers together are called real numbers. Rational numbers and irrational numbers together are called real numbers. So with this in background, let us look at the first statement. What is the first statement? The first statement asks, every whole number is a natural number. So shall we see the diagram again? Every whole number is a natural number. It's not true because 0 is a whole number and it is not a natural number. Because 0 is a whole number and not a natural number, the statement is false. So this is false because 0 is a whole number but not a natural number. Now let's look at the second question. Every integer is a rational number. Every integer is a rational number. Yes, every integer is a rational number, as you can see in the diagram. So every integer m can be represented in the form m divided by 1, so p/q format, and so it is a rational number. Now let's look at the third statement. Every rational number is an integer. Every rational number is an integer. That is not true. As you can see, in this case, half and -3/4, they're rational numbers, but they're not integers. So false, as an example, 3/5 is a rational number but not an integer. Okay. Shall we look at some more? Let's look at some more. Let's look at these three questions. Okay. What is it? Every natural number is a whole number. Every integer is a whole number. Every rational number is a whole number. First question. Every natural number is a whole number. All right, so let's see how the natural number looks. Every natural number is a whole number. Yes, all natural numbers are whole number. So this is true. The natural numbers are 1, 2, 3. Whole number starts with 0, 1, 2, 3. Hence, it is true. Now let's look at the second one. Every integer is a whole number. Every integer is a whole number. Shall we see? Every integer is a whole number. No, the negative integers are not part of whole number. Whole numbers are 0, 1, 2, 3, 4, whereas integers has negative as well. Therefore, it's false. Every integer is a whole number is false because an integer can be negative, for example, -1, while whole numbers are always positive like 0, 1, 2, 3. Let's look at the third one. Every rational number is a whole number. Every rational number is a whole number. It is not true because rational numbers can be -3 by 4, 1 by 2. It can be negative integer, whereas whole numbers are only 0, 1, 2, 3, 4. As an example, 1 by 2 is not a whole number and it is a rational number. So this is also false. Shall we do more? Let's look at these three questions. It says every irrational number is a real number. Every point on the number line is a form of root m, where m is a natural number, and every real number is an irrational number. Okay, let's take the first one. We'll again use the diagram. Let's look at the first one. Every irrational number is a real number. Okay, let's look at irrational number. Irrational number. Yes, all irrational numbers are real numbers. It's true. True. Since the collection of real numbers is made of irrational and irrational, it is true. Now let's look at the second one. What does the second one say? Every point on the number line is a form root m, where m is a natural number. So what is it saying? Every point on the number line, that means all real numbers are of the form root m, where m is a natural number. Okay, let's see. So we're saying all numbers on the number line are of root m, where m is one of these. False, because there are points of the line, like points on the number line, like 1 by 2, which are not of the form root m, where m is a natural number. So 1 by 2 cannot be written as root m, where m is a natural number. So 1 by 2 happens to be 0.5, and we can't find a number m where it is possible to do root m, hence it is not true. Now to prove every point is not true, that to disprove this, to say that this is false, we just need one example. If you find one example, then we can just say that this is false. And all we needed was one example here. Last one. Every real number is an irrational number. Now this is obviously false. Every real number is not irrational number because we have a whole set of rational numbers which is not irrational. False because real numbers also include rational numbers. 2, for example. Thanks for watching this video. Soon we'll come with you a new video. Till then, bye.